Just want to welcome you all to the derivative trading tutorial, and I'm sorry that we are asking you to come out on a Sunday afternoon. It's not what I would like to do on a Sunday, but I have an obligation to give you everything that we promised to deliver according to the schedule. So I'm doing it, and once more, you will actually learn something, we guarantee. Now, quite a bit to do today. What I am planning to share with you for the next hour and a half. So I got some questions regarding the assignment number 2. So we'll go through that briefly, but I have to strike a balance between not telling you enough and telling you too much. And I have to strike a balance between giving you guidance when you truly have a problem understanding. I have to strike a balance between that and telling you how to do everything, including how to download data. Quite honestly, if you can't figure that out, you don't really have you shouldn't be in finance, okay? To be quite honest. But anyway, I'll make sure I give you sufficient ideas and guidance so that at least you know at a conceptual level what you need to do. That I will make sure, okay? As to when you go to Bloomberg, when you go to the trading lab, when you open a spreadsheet, you know, which button do I press, which command do I use? Well, that doesn't take long, but we'll get on to that, okay? That doesn't take long for you to figure out. So what I plan to do today, mainly I want to give you a few clues on assignment number 2, and I'd like to get on to the practice questions set number 3, which has been uploaded to Blackboard, the clean one, with no answers and no annotations, and we'll go through that. Just quickly, by way of keeping you up to date. Now, very shortly, I will ask you whether you can tell me the answer to, I deliberately left out question number 16, the last one, for set 1, and then for set 2, I left out questions 8 and 9. So I'm going to invite you guys to tell me what the answer is, but not just the answer, but can you actually explain it, okay? And if someone wants to put their hand up, you're very welcome to. You will get some points, real points, that will go into your score, okay? And so real money, not Bitcoin, okay? Real, you know that, okay? Now, P points is participation points from 1 to 3, depending on the quality and detail of your answer. So next lecture, obviously, is not February the 9th. It is going to be 14 days after that, so it'll be February 23. So 2 Fridays away, okay? Now, this is where we are today. Unfortunately, we will meet next time. We will also meet on a Sunday. I do apologize. And so next time we meet, it will be the 25th. And I will give you, we'll spend 3 hours together. And so it's going to be a double tutorial. My experience is that the last tutorial, there's always a lot of questions, but I would prefer you send me the questions before. But if you were to ask them during the class, it's fine. Okay. What I prefer the least is we already finished and people are packing their bags and leaving, and then if you come up, because then I can't share the answers with everyone, which has always been my preference. Okay. Likewise today, I actually have another tutorial starting at 3:45, so I can't talk much with you guys after this one's finished. Okay. The exam will be somewhere around 6:30 on Friday evening on the 2nd of March. So please make sure you are available. Okay. And the assignment 2, actually, I think I set the due date the day before. I need to check that. But anyway, I'm sure you finished the exam at 9:30 on the 2nd of March. Even if it was on the end of the same day, do you really want to go home and do your assignment? I don't think so. Okay, so it's really up to you to manage. But that's the deadline anyway. Okay, but I recommend you. Some of you might even try to finish it during the Chinese New Year, and you're welcome to. Okay, more on that in a moment. So this is the calendar. The YouTube video for last week. That is last Saturday. It is online, so you can go and check that out if you want to. This may be the only course in the entire program where I have been taping the tutorials every single time. So today I'm doing that too. Okay. Now, so this you know. Now, I got some questions regarding assignment. This is all about assignment number 2. Okay, and I want to thank the person for writing to me, taking the trouble to write all that out. I will give you my responses to all of these, and I think they are valid and reasonable questions, and I will answer these. Okay. It's a little bit different to just ask me, what do I do in front of a Bloomberg? I'll talk about that too, okay, in a moment. What I want to do for now is I'm going to turn to question set. This is question set 1, the last question, and we actually left this one out. Now, would anyone like to try to answer this one? Sir, yeah. C. Okay. I'm gonna, bless you. I'm gonna exercise my privilege here that I am not able to in the exam. I'm gonna ask you why. Why C? Approximately, let's say.
Only B or C is correct. So then we turn to gamma. Gamma 1, so we only choose C.
Say it again. I think I heard you, but I just want to write as you speak. Okay. Can you talk a little bit slowly? So yeah, go on. Yeah. Yeah. B or C. Why is that? Why is that? Yeah, very good. Now, okay, I'm going to take this like in slow motion. If you are long the put, okay, if you are long the put, your payoff profile is like this. You know that. And if you are long the call, if you're long the call, so this is long put. This is long the call. And therefore, if you are short the call, it's just like the mirror image. Now, for answer A, if you are long put and short call, you are adding these two up. Okay, so sometimes you need to have a kind of graphical imagination. So when you add these two up, what are you? You're basically short. So you are short, you cannot be delta flat. Okay? Delta flat means for a small amount of movement in the market, you are not actually affected. So he's right to say that you cannot be, A cannot be the right answer. Now D also cannot be the right answer. So you are long and you are long. In this instance, they are both calls. So when you are long a call, you are long delta. You're long delta, you must be long delta. Okay, so he's correct. Can you keep going? Yeah. 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 Very good. Yeah. Yeah. Very good. Okay, now, so just to reinterpret that, he's correct. He knows what he's talking about. If you are long an option, any option, long, okay, let's talk about long call, and then we talk about long put. Now, I have actually said this before. So as far as delta is concerned, you are long delta, okay? As far as gamma is concerned, you are long gamma. And I can't scroll up. Vega, okay? You are long Vega. Long Vega just means if volatility goes up, you're actually quite happy, okay? And of course you are. And it doesn't matter whether you are holding a call or a put. Now, for the second order Greeks, like Gamma and Vega, actually they are in the same direction, but as you know, when you are long a put, you are short delta. And for theta, so I prefer not to talk about being long or short. And you notice Governed also doesn't do that. So you are paying theta. You're paying theta. Anyway, theta is not part of this question. So you can tell right away that for answer B, you are short option. Never mind what kind of option it is, okay? You are short option, you cannot possibly be long gamma, okay? So you are gamma short. So the only acceptable available answer is C, and not only just by elimination, but C actually does make sense. So when it's at the money, the delta would be approximately 50. So for the purpose of these questions, you just assume that you can be delta flat, okay? You are gamma long because the gamma of a short-term option is higher than the gamma of a long-term option, all things being equal, okay? And you do pay theta, okay? And you pay theta because you are long a call, which is shorter term, and you are short a call, which is longer term. Now, just as a very quick recap, I'm going to call up our old friend, optionprice.com. And we have kind of gone through this actually very near the very beginning, but here's a standard, good old-fashioned, boring at the money call or put with a strike at par. And you can see there's a theta value over here, which is 0.054. So this number has some meaning. It means that if you change 30 to 29, okay, so 29 days left, and nothing else changes, then the price will go down by around 5 cents. Okay, you can see that happening. Now you should immediately realize it goes down by 5 cents for 1 day, and because this option has 30 days more to live, then if you multiply 30 by 5 cents, actually you only get 150 cents, which is $1.50. But you can see that the price of the option is actually $3. Okay, that's the first thing you can figure out. The second thing is do not. If I was to ask you what the theta is, okay, which is just dc by dt, you cannot just take this price here and divide by 30. Do not ever do that. Only an amateur would do that. The time decay of an option actually accelerates towards the end, as I have demonstrated to you. So if you change that to 5, so it's only got 5 days left. Look at the theta, okay, for the call. So now it's 0.05, but it's going to really rush up to quite a high value. Okay, 12 cents. But 12 cents, 5 days left. If you multiply 12 by 5, it's still not equal to $1.20. Okay, so what if you change that to 2? Then it gets even more extreme. Okay, now you're losing 20 cents a day, and one day, if nothing happens today, you're going to lose 27 cents from that is basically 27 basis points. Okay. So if you have a longer option, then the time decay is slow. It's kind of like a balloon. Okay, if it's a big balloon and it's slowly leaking the air, by the time you get to the end, the air actually comes out very, very fast, as you know. Okay, this is kind of similar, and okay, trying to. Bless you. All right. Okay, now where were we? Still talking about that. Yeah, so then, now another way you can try to figure out why the theta of a short-term option, so theta short-term is also bigger than theta long-term. Now, why is that? Because the theta, which is the time decay, the theoretical expected drop in your option value is actually equal to 1/2 times gamma times the volatility. Now this is just, I'm just re-quoting the formula, okay? And assuming, oh, I don't have any more space. So obviously, if you don't change this, if you keep the vol constant, so this doesn't change. So as gamma goes up, which it does for shorter term options, so theta has to go up. And as gamma goes down, theta also has to go down. So that should make sense to you. That's another way of thinking about it, okay? Sorry, I know your name. You are, it's Sunday, forgive me. I want to give you 3 points later on, remind me, okay, for participation. All right. Okay, now let's have a look at the other. So let's have a look at set. So everyone is okay with that? Okay, I want to have a look at question set number 2. So this one also is already in Blackboard. So there is a clean version. There is a version that I have annotated. I don't think you need the version with the answers because I already circled them here, okay? But we didn't do questions 8 and 9. Does anyone want to have a go at that? Anybody? Sir, Axel, good afternoon. Yeah, so you have the following option portfolio. They did mention portfolio, but doesn't matter if it's 1 option or 10 options. So you are delta flat, you are 200K gamma long, 200 Vega long, vol is 32. They tell you use this for theta calcs. Share price now is 5. The share price drops 15 cents and the vol drops half a point. Your daily result, including all components, is what? You pick E, the last one. Okay, yeah, can you, yeah. Yeah, daily, yeah. Okay, so for theta, you will be doing this just as we discussed just now, okay? Didn't we? So we can tabulate these one by one. It's like going to the supermarket. You take them off. Except here is a supermarket where you pay for something, and for some other stuff you get money from it. So gamma, thank you. And then the vol is 2% times 5. Yeah, so that's 100K. Yeah. Yeah, what is 2% of 5? It's 10 cents. It's the square of this, which is 0.01. So that makes it 1K, doesn't it? Okay. Okay. So that's theta out of the way. By the way, you pay this. Okay. The reason I know that we pay this is if you are gamma long and Vega long, gamma is a wonderful thing, but you have to pay for it. And so there's no way you can be gamma long and then still receiving theta. Okay, so that's $1,000 down the tube. So this $1,000 is the $2 million I was telling you earlier. Okay. Yeah. So keep going, please. Yeah. 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 Yes. Yeah. Is that good news or bad news, do you think? Very good. Okay. Yeah. Yeah. Now this one is minus. I'll put a minus. Before I forget, I'll put a minus. Very important you get the signs correct. Um, oh, this one is a plus. Yeah. Nearly got that wrong. Okay. And then what's the last item? Yeah. Yeah. You can call that Vega revenue or Vega income, whatever. But this one actually works against you. Right? Yeah. So you are two. So you lose another 1K here. Okay. So you have lost 1,000. You lost another 1,000, but you make 2,250. So end up you have a profit still of $250. Okay. Now this is actually a good resemblance to a real live situation where there is the volatility drops a little bit, and then you also have to handle the time decay, but still, because there is more movement than anticipated, you end up making a little bit of money. Okay, very good. Remind me to give you 3 points. Okay, now how about somebody else for question 9? My option price shows me the following. So share price 65, delta 40. It's unclear here, by the way, whether they are talking about one option or 100 options. You might have a book, but it doesn't really matter. You manage these Greeks. That's the whole point of option trading. You have a book, and then you manage all these Greeks, in totality. And anyone wants to have a go at this? Nobody. All right. Yeah, sure. Go ahead. Yeah. Don't say that. Okay. No need to say that. Yeah. Yeah. Hmm. Yeah. Yeah. Okay. Now, let me. So which is the right answer? Which do you think is the answer? I think B is the right answer. Okay. Now, I have said to you before that quite often when I'm working with these problems, I like to kind of put imaginary numbers, and we did that all the time previously. Like here, for example, the gamma of 7 and then -3. These numbers I made them up for a kind of relative or comparative analysis in my head. So, I become clear on the direction. In this question, they are actually kind of forcing you to do that, which I think is good. And if ever you have some doubts about this, now, first of all, I take one look at this, all right? All right, let me ask the question another way. If this was just one option, okay, never mind what kind of option it is. Are you long option or are you short option? Huh? You're long option. Why? Very good. Remind me, you can do a scan for 3 points later on, okay? Now, you must be long option because you are long gamma and you are long vega. Now, my second question to you, it's like Sherlock Holmes, it's like detective work. What kind of option are you long now? Put option, right? Very good. So looking at this, you know you are long option, okay? And then you look up a little bit, you can further deduce you are long a put. So your payoff looks like this. And third question to you, is your option currently in the money or out of the money? You can tell as well, just by looking at it. Why? Very good. Okay. So if this was your payoff, then this is a map. And you know how when you're on a map and they tell you are here. Well, right now you are here. I can't draw these things very well. Okay. So we are kind of asking you to imagine what happens when vol goes up. Now, if you have difficulty thinking what happens when vol goes up, sometimes I try to think the other way. What if vol goes down? If vol goes down, then your line becomes like this, and then your delta, oops, I wiped everything out. I'm trying my best, okay? So you can see that if vol goes down, so you long a put, okay? And vol goes down, actually your delta for out of the money, let me do it the other way. So delta of out of the money options, it actually goes down, okay? Because your delta, it was like this, and now it's like this. Okay, so this might be, let's say, well, they told you it's 40. So this one would be something like 478. Okay, but at least the absolute value is going down, okay? Because to go from minus 40 to minus 38, you could say you are going up, but the absolute value is going down, okay? Now, I might as well tell you here that when it's in the money, the opposite is happening, okay? I think I have told you this before anyway. So if you were here, okay, then now suddenly you are here. You can see that the line has gotten steeper. Okay, so the absolute value goes up now. However, but now it's the other way around. So the arrows go the other way. So whatever the delta was, it now needs to be higher. Okay, so it would be either A or B, and you have to also figure out what happens to the gamma and what happens to the vega. Okay. Now the thing with the gamma is sometimes called convexity, which is another word for curvature. How curvy, a curved line is. So for example, a line like this has far more convexity than something like that, which is smoother. At least within this area, that is certainly the case. Okay, so this is higher convexity or higher gamma. But now we are actually going the other way. You are raising volatility. Okay, so your gamma actually will drop. I have an annotated version somewhere. Might be easier if I just show you that one. Question 2 with answers. The correct answer, I thought I had some notes in here. But A is the right answer because, as I said, gamma will decrease because your line is not as curved, okay? Now, the reason vega goes up is that, let me try and draw this here. Vega is a measure of how sensitive your option price is when volatility itself changes. And when you have an option or two options, now vega will always be highest somewhere around here, because you can imagine this part here is what we call optionality. This is really the premium that you are paying for that privilege. And the thicker this area is, okay, the higher the vega. And when you raise volatility, and let me use a different color, your payoff curve now becomes like this. So naturally, this area would increase. So of course your vega would go up, okay? The best way for me to show you actually is by just I think this one may be a good way to show you. What happens to your, okay, we are talking about a put, okay? What happens to the put gamma as your volatility goes up or down, okay? Now, as you can see, what is changing actually, what's changing here is not on the x-axis, because we are keeping everything constant except volatility. The changes are occurring on the y-axis, and as volatility goes up, the put gamma is going down. Can you see that? 0.04, 0.03, 0.02, 0.01, and so on. Okay, So when you play around with this, you start to understand what I'm talking about. Okay. In fact, this question really is about, looking at the various Greeks and then what happens to them when you play around with the volatility. Okay. Likewise for the Vega, but it's harder. This one is harder to detect. Okay. So thank you for your answers on these. Now, what I want to do now is to tell you a bit about the assignment. I received these questions. Now, you might want to. What I think we'll do is just very quickly, just spend a couple of minutes reading these questions, and then I will give you an overview of the assignment and what we're looking for. And then when we come back, it should be quite clear to you what actually you need to do. Okay? So I'm going to pause this. Maybe I will just very quickly go back to Govert's notes and make a reference to them. And not this one, it's the set on volatility arbitrage. Now, the simple idea is that when you look at an index of anything, but let's pick a stock index to start with. So what is a stock index? A stock index is simply a basket of what we sometimes call constituents, or members. So in a stock index constituent, there are certain members, and when you see, the Dow Jones, S&P, Nasdaq, CSI, they're all the same. Okay, so when you see an index, the value of an index is going up, it actually just means that the basket members are going up. Now, the interesting thing is, when an index goes up, it doesn't mean everybody in there is going up. Okay, it's very, very seldom. I wouldn't say never. Okay, it's called market breadth. BREADTH. The number of advances versus number of declines and so on. How many stocks are going up versus how many stocks are going down. But it will be very, very unusual that everything is going up. But if that was the case, then of course your index is going up. It may well happen when it's the other way, sometimes, that when the index is going down, when it's crashing, everything is going down together. That's more common. Okay, but anyway, that's a side issue. The funny thing is, if you have an index and there are members 1, 2, 3, 4, then if 2 of them go up and 2 of them go down, then what ends up happening is that your index value may not change, or it may not change a lot, okay? But if you are long call here and long put here for your individual members, you're going to make some money, aren't you? Because let's say you are long calls and long put for the individual members, and you are short the call and the put for the index. You can't do that. You have to short the futures on the index. Okay, you short the call and put options on the index futures, for example. Then here you definitely will make money. Okay, because you are winning here, and here you don't have any, or you have very little gains or losses. And in fact, if the index doesn't move at all, okay, then you don't lose any gamma revenue, and you will pick up on the time decay. You pick up on a theta. So it seems a very good position to be in. Okay. Now, of course, it's not that simple. If it was so easy to make money like this, you don't need to go to college. You just do this whole day. Okay? The reason this doesn't always work is that you need to pay for it. Okay? Which is to say, when you are buying the calls and the puts here, and you are selling the calls and the puts on the index, it's very likely to cost you money. Okay? You have to pay for it. And number one, okay? Number two, this may not always be profitable. If everything moved in the same direction, everything moved by the same amount, okay, then this strategy will not work. In other words, when they are very, very highly correlated, this strategy will break down. Now, so I said just now, you actually have to pay for it. So this strategy, it's going to cost you. And how much do you pay? How expensive actually is it? Okay. Now, that value or the cost of it actually can change over time depending on the volatility of the index. So I'll put that on top, okay? Relative to the volatility of the individual components, okay? The individual stocks, the individual. Okay. What you really want to do is, now because you are selling this and you are buying this, okay? So this is a strategy. So if you are long the calls and the puts of stocks, you are short the calls and the puts of the index. If you are doing that, okay, first of all, you need to pay, number one. And the one measure that we use to see whether this is expensive or whether this is a good time for you to do that is we look at this item here. Okay, now this is so Govert calls it the null relation. You see that in his notes. And this is simply just taking the volatility of the index and dividing it by the volatility of the individual. But you have to weight them by their, you have to capital, you use a weighting by market capitalization, okay? I don't think you should just divide by 25 or whatever, okay? You should weigh them according to their contribution in the basket, okay? But of course, when you are selling something on top and you are buying something at the bottom, which is what you are doing, okay? Before you do that, you want this value to be as high as possible. If it's high, it means either what you are buying is cheap or what you are selling is expensive. But after you've done that, after you've done the trade, you want the opposite to happen, okay? So in a way, when you are doing a trade in this direction, so you are paying theta and you are, in summary, you are short the no relation, okay? And this value, the highest value it can take actually is 1, okay? So if it was 1, that's perfect. That's the best time for you to sell because it can only go one way, okay? But it's very unlikely to be 1. And when you look at his notes, so just very quickly, I think it's around page 20. Okay, so here is just what I've been telling you. So you got an index with stocks, 4 of them, and you will actually start making money if they go in different directions. That's the best case. Now, because you have to pay for that, then there's a question of, what is a good timing for you to do this? And I should mention this item here. There is no such word. You're not going to find this in textbooks. This is an idea that they have come up with in this company. If you do a Google search, I don't think you'll find that. Okay, so it is not an idea that's out there, which is widely. Well, it might be discussed in some circles. Okay, it's just you won't find it in textbooks. Okay, so don't bother looking. But what you are doing here is you are looking at the index volatility, and you are measuring that against the components. And before you do your trade, you want this to be as high as possible. It's like when you are shorting the market, of course you want the market to be as high as possible, right? And the average here, you have to be careful. You actually have to weigh them by their size within an index. Let me go back to the questions. Okay? So normally correlation just refers to the teacher asks us to compute the correlation of one index. Is it just using variance over average variance? Yes, but just be careful with the average. Okay, so you should weigh them by the market capitalization to see what is their contribution. Okay. The assignment distinguishes implied correlation from realized. I consulted the internet and lecture notes for the difference, but there's no exact difference because this thing, they don't teach you in textbooks. Okay? Does that mean we use the square of implied vol of the index over square of the average? Yeah, I would say weighted average, implied vol of the stocks to get the implied correlation, and the square of the realized vol of the index over the square of the average realized to get the realized. Yes, I would add 2 points. One is that you need to weigh them by market cap, and in this context, you could substitute the word correlation here by the word correlation in Gover's notes. Okay, in this context, they are interchangeable. Okay. Number 3, I wonder there is an easier way to get the variance of each stock within the index. Is putting the stock price into Excel for tens of times the only way? Well, we are asking you that question. If you were ever to join a hedge fund or a trading firm, this could well be something they ask you to do within the first 3 weeks. And you wouldn't be able to ask your boss, how do I do this? the first point I want to make is that it can be done. Okay, number one, your best bet is probably to go to Bloomberg, and in the trading lab. Okay, you start up Bloomberg and you start up Excel at the same time. There is an Excel Bloomberg add-in, and you need the API interface. Now you should be able to find that somewhere on the spreadsheet. When you open up Excel, there will be a little icon, which I don't have here. For example, when you open up my Excel, it stops, but it will be somewhere on the right hand side. There should be an additional icon or button for you to download data. Now, just to give you a bit more guidance on this, okay? So we don't have data stream, so you won't be doing that. But for Bloomberg, what you can do is you can go to Bloomberg, and then if you're using the HSI index, so after you call up the index, you just type, HSI index and go, and then it should start showing you a whole load of information. And then when you type MEMB, MEMB, and you hit go, it will show you all the members that are in that index. And then there should be a button in there that will allow you to start downloading data, either spot price data or historical data. I know you can because I've done it before. Okay? But I'll leave it to you to explore. And are you aware that when you are on Bloomberg, if you have a question, if you press F1 2 times, there is actually somebody who will take you up on a live chat, and you can start asking questions. Did you know that? Now, those people are always very helpful. I think out of 100 times, 97 times they manage to answer my question, as long as I ask it properly. So if you are in the trading lab on a Saturday night and you're feeling really lonely, and you might just you can actually there's someone on the other sid. I used to have friends who work in that kind of desk, and they will help you. They will let you know. Okay, just ask, let them know exactly what you want. Okay. Now, I don't mean to be unhelpful. I really don't. But this is the first time you guys are doing this course. It's not the first time I'm covering it, and my experience has always been that if we just give students a kind of top level guidance, which is what I'm doing here, they're pretty okay. They will run with it, and then when they start asking questions, on a second level detail, and then I talk more, and then they go down one more level, and then it just doesn't stop. Okay, but I discovered that when I just tell them about the concepts and the direction, they really can just run with it. Okay, so I think I'll just leave it at that. Now I can show you one more thing. Where is that? Okay, I have, this is something I knocked out before. Now in here, so this is actually the result of a Bloomberg download. No, you don't have to type it in. You don't have to type it all in yourself. No, you don't. Okay, so you can organize it for Bloomberg to download the historical data. So here is the HCEI, and So what you can do is and they give you the index weights, and then don't worry about the number of shares, price, the 30-day implied vol, and then the historical 30-day vol, and then what is the weight of that index, and then what is the volatility that you can use. Now, you can see there's a formula up there. So what we're doing is, so for this one, which is HSBC, hold on. No, ICBC, sorry. So the implied vol was 23, but the historical 30-day vol was 34, and then you would use the 23. Now, in some instances, the ones that are highlighted yellow, okay, then what are these? So they are very small companies, Sinopharm Group. So at the time, they didn't actually have an option market. Then there are two things you can do. Number one, either you just ignore it, and then you have to reweight. You have to reweight the remaining companies, which is why the original weights might be these ones in column U. But when you ignore those firms that you're not going to use, the weights of the ones you are going to use, they will be lifted up. That's one way to do it. Okay. The other way is just to use the historical volatility. Okay. Use this one. Now let me try and tackle all these questions. So we've done number one. We've done number two. Number three is easy. The assignment asks to use only stocks that have options listed. Does that mean we need to construct a new index by applying the construction methods? No, you don't need a new index. You use the old index and you just try to figure out which stock in that index currently either does not have any available options, or if the liquidity is very poor and therefore the data quality is very poor, then just don't use it. Okay, it pretty much, in fact, by showing you this one here just now, okay, we are already doing that. Okay, so you don't construct a new index. You just ignore the ones that don't have options, and either you reweight or you just you use the historical vol. Okay. In fact, that was specified in the assignment itself. Okay. What else? I kind of got lost in this sentence. Okay. For each index, calculate a rough basket versus index implied null relation using all stock weights. Therefore, you need to proxy the stocks without options traded by using realized. Well, again, it's related to what I just told you. There are two ways to do it, and this is related to method number 2. Okay, so let me go back to this spreadsheet. So now you have an index. Actually, in the Hang Seng, a lot of them do have active options, but HSCEI is a little bit different. Okay, so here you have an index, and these are the stocks: CCB, BOC, Ping An, China Life, PetroChina, and there are some smaller companies, such as Sinopharm, New China Life, or CITIC Securities. They do not have an option market. Okay, now actually they might have that now, because this was a little while ago when I did this, but some of them don't have an option market. So we are asking you to work out what this is, okay? The implied volatility of the index divided by the implied volatility of the components weighted. Problem is, this is not available for some I. Okay? So what do you do? What to do with that? That's the question. Okay? That is what that sentence is referring to. So there are two ways you can do it. Number one, ignore the ones that don't have any weights. Okay, so if before they had, so stock 1, 2, 3, 4. So if before they had equal weights, this is a very simplistic example, and one of them don't have options, let's say number 4, so you're just going to ignore that, and all the other ones become 33. Okay? Now that's one way to deal with it. The other way to deal with it is to say that, all right, well, they don't have an option market, there's no implied vol. First of all, what is implied vol? Implied vol is just this, okay? And every one of you should be able to answer that question, okay? What is implied volatility? Now, when you price an option, look at all these parameters. Underlying price, you can observe what that is. Exercise price, you know what that is. Days until expiration, of course you know. Interest rate, you know. Dividend yield, you make a guess, okay? Anyway, it is not the most important parameter. Now, this one, volatility. What is that? What the hell are you putting in there? That's my question, okay? That's what you need to understand. Now, for anything that you care to price, there are really only two volatilities. Okay, let's take a stock. Let's take CCB, for instance, China Construction Bank. And right now we are here. Okay. There are only two volatilities. There is the realized, and there is the implied. Now, what is realized? Realized is you look back, you look at how volatile the pricing is, you put all the returns in a spreadsheet, and then you just calculate the standard deviation. That's it. Okay, that's the realized. It's like when you are at this point and you look back and you want to see how volatile the stock is. Now, implied is you don't know what would happen. So you're right here. This is now. You don't know what would happen. Okay, but you're going to make a guess as to how volatile. Is it going to be like this, or is it going to be like this? Okay, and you characterize that by guessing on what kind of distribution. So obviously, the higher the volatility, the more dispersed will be your bell shape. Okay, that's all it is. Okay, don't think it's complicated. It's not. And the reason I think options are so fascinating is that for me, it is the only market where participants are making a view which is forward-looking. They are trying to predict, rightly or wrongly, okay, what is likely to be the price pattern, not the direction, but whether the price is going to be like this, or whether it will be like this. And it's forward-looking. So for any underlying, there are really only two volatilities you need to care about. Okay. So here, for each index, calculate the implied null relation using all stock weights. Therefore, you need to proxy. I think by now it should be clear. So you need to proxy. You need to substitute the stocks without options traded by using the realize. Okay. Okay. So question 6. We learned the implied vol of options. If I remember correctly, it has something to do with strike price, kind of. We also need to input some other parameters to Black-Scholes to get the implied vol. But what about the implied vol of stocks and index? The comments in square brackets are from me, okay? And I'm saying here there is only one implied vol for an underlying. There is not an implied vol for stocks and its option. In other words, when you are, let's just talk about stocks, okay? So CCB. So there will be a volatility for CCB, which is the realize, and there will be a volatility for CCB, which is the implied. And now this is based on the CCB stock price, okay? Now with these two volatilities, you can price options. You can price options on CCB. So the volatility refers to the price dispersion of the stock price. You don't have a volatility for the stocks and then a different volatility for the options. That's the wrong concept, okay? So the volatility is the volatility on the return of the stock price. An option is using that same volatility, which is this one, to do the calculations. Okay, so whether it's options on the stocks, okay, or whether it's futures on the stocks, or forwards, or swaps, or whatever. Okay, there is only one volatility looking forward, and there's only one volatility looking back. This one is the realize, and this one is the implied. Okay, now the reason it's called implied. The reason it's called implied vol is that sometimes in a lot of option markets, you are trading on price terms. So you know what is the price of the option, and from there, if you know all the other parameters, you can actually reverse engineer and try to back out what the volatility is. That's why it's called implied. The volatility is implied from the option price. You see what I'm saying? Yeah, and of course the option price is forward-looking. Okay, so there is not a vol for options and then a vol for stocks. No, that's the wrong way to think about it. There is only one vol looking forward, and that vol is simply the estimated, okay, I'll say it slowly. We are, so here's time. Now you are here, right here, okay? And for any stock or any index for that matter, okay, there are only two volatilities. One is the one looking forward, called the implied vol. Now, what is that? That is simply the estimated probability distribution or shape of the bell going forward. So whether it's going to be like this or to use a different color, is it going to be like this? Okay? Looking forward. Now, looking back is what we call realized or historical. Now, here there are no arguments. You simply take a chunk of time, and in the case of our assignment, 30 days, and you just measure, you just take all the returns from the prices, and you do it in Excel. You find the standard deviation. It will take you, 90 seconds to do that. Okay? Literally, you have, day 1, 2, 1, 2, 3, 4, 5. Okay, and then you have prices. So you start at 100, and the day after might be 101, 103, 99, whatever. Okay, you have to take the log of that. The log of the, first of all, you calculate the return. Okay, so return is equal to this divided by, now, if in doubt, now I run the danger of telling you too much because you should know all this. Okay, this is undergraduate stuff. So now you have the return, and you take the log, the natural log of the return. So you just log this thing. Oops. And the standard deviation is the standard deviation on column D. Okay? If in doubt, guys, ladies and gentlemen, you don't need me. There would be 1,000 textbooks out there showing you how to do this, but while we're on the subject, I don't mind telling you. Okay? Yeah? So do not get confused thinking there is a vol for options, there's a vol for stocks, there's a vol for what else? Vol for stocks, vol for indices, no. It's the same concept. It is the same input that we are thinking of. Okay? Now, I've kind of accomplished what I wanted to do today, except that one big item, which is the practice questions for set 3. You know what? I said we are going to meet. We're going to meet on the 25th of February. And we're going to make, now that is actually a Sunday, okay, so my apologies. So we do have quite a bit of time. So we'll be meeting like 5 days before the exam. I think by that time I will go through with you, and I might do that earlier. If I have some time, I will make a video with all the answers to the questions, which might be a good idea. And then you can review that in the next 2 weeks. Okay? I hope that's been helpful. Does anyone want to ask me anything? Please? We do have a few minutes. Oh no, we don't. It's 3:44. Anyone wants, just very quickly, anyone wants to ask anything on the assignment? Please. Anybody? Oh? Um, you know what? When you write your report and you're going to ignore some stocks, and if you tell us why and the assumptions that you are using, when an option market is very, very poor, you can see that in the data quality. You can see the bid offers are wide and the prices are just not trustworthy. So that should be quite obvious. So I don't want to give you the limitation. Oh, do this, do that, or don't do this. So you can use your judgment and just tell us what your judgment is. Okay? Yeah. Well, I might not see you again until next year, Chinese New Year. Okay, so I wish you a very happy holidays. Take care, stay safe, don't eat too much, and all the best. And thank you for coming in on a Sunday. Now, those of you who have not signed in yet, can you please do that now? And those of you, I promise to give you participation points. You can come up later, okay? And we can do this. We can do the scan. But the attendance is this one, please. Okay. So please do that because I need to shut that down soon.